Hi, this is Chris Barkley, and I will be talking about algae as a renewable energy source. The end of non-renewable energy sources is near, as depicted in this graph, which shows the energy output from 1970 to present to the estimated amount in 2100. The bottom three lines to show oil, coal, and natural gas output of energy. And as you can see here, all three have a significant decline in the next 100 years. On top of this, all three are expected to run out in the next 150 years. Above that in the purple is nuclear energy. This is one of the few non-renewable energy sources expected to grow, though it is not growing near enough to supply our nation's high energy demand, nor can it fuel cars that run on gasoline. This shows that we need more renewable energy, especially when only 6% of our energy output right now is from renewable energy sources. It needs to be closer to 90% when coal, natural gas, and petroleum will all run out soon. Solar and wind are not reliable due to the sun not always shining and the wind not always blowing. Then there is also geothermal and hydroelectric, but these are not good for the environment and can only be built in certain places. This leads us to biomass, and we will be looking at a certain type of biomass. One may ask, why algae? When you see these numbers that depict the amount of oil that can be extracted from these plants in gallons per acre, it should be easy to see why one would choose algae. Algae has almost 3 times greater content yield of oil in a gallon an acre than the next leading one of oil palm. And the potential of microalgae is ridiculous. It is expected to possibly be 1,000 times greater in corn, which is our most used plant for extracting oil right now. Pros of using algae consist of being renewable, so it can be used over and over again. It is scalable, so this means that it can be used on the large scale once enough factories and farms are built. It leaves a low carbon footprint behind due to the fact that taking in CO2 to create the algae which extracts the oil from. Then it can be farmed in non-agricultural areas and does not compete with food or water resources, so this means that farmland is not competed with since it can grow in deserts, and it uses salt water, so fresh water does not have to be competed with, and it does not use any food beyond CO2 and sunlight, and there is an abundance of these. Then also, it can fuel traditional engines and is compatible with existing infrastructure. So new engines and factories do not need to be built to deal with algae coming in as a renewable energy source. How it works. Sunlight and CO2 come in to make the algae grow. The algae give off an oil, and this oil is extracted and sent to factories, and also when the oil is extracted it gives off protein products. When this oil is sent to factories to be made into gas, it gives off glycerin products and oil. This oil can be used to fuel our nation's high energy demands and fuel our automobiles. These automobiles will also give off CO2, which will go back into the making and growing of algae. Challenges that algae faces to become a legitimate renewable energy source is that the cost of algae oil is $8 a gallon right now, but is expected to become much lower when companies finally start putting money into research it. And this leads us to our next challenge, getting companies to pursue algae as a renewable energy source. Right now, very few companies are looking into algae as a renewable energy source. And to get companies to do this, it will take time. And once they see the potential of algae and that there needs to be a new energy source, since all the others will be running out soon, they will be on all over it. Then the amount of algae on the large scale. It'll take a long time to get enough farms to fuel America. The only good thing about this is that it can be trickled slowly into our nation, since it does not need new infrastructure to be compatible with. And then another main problem that cannot be really dealt with and just needs to be accepted is that it gives a lower energy content than that of traditional oil. But since traditional oil is expected to run out, is something that people will be willing to deal with. There's 4 types of systems that algae can grow in, but only 2 main ones that are being looked into seriously right now. First is the open pond system, which is cheap, but it has problems with environmental factors, such as the sun not always shining to help grow the algae, and the wind, which can blow in different brands of algae, which would yield lower energy contents, or ice, which could freeze over the algae and halt production. The next type is a bioreactor system. This system is much better than the open pond system. In fact, it solves all the problems that the open pond system has. The only problem is that it is really expensive, since it has artificial sunlight and feeds in the CO2. The next system, which is in just the research stage of getting, is the greenhouse system. This is a combination of the open pond system and the bioreactor system, and it is relatively cheap but more expensive than the open pond system, but it gets rid of most of the problems that the open pond system has. Then there's a seaweed farm, which is pictured here. This just takes advantage of algae in the ocean and gets oil from that to fuel our nation. Though this is in the very beginning steps. The plausibility of algae as a renewable energy source in the near future is grim, especially when very few companies are looking into algae as a renewable energy source. However, once fossil fuels start going down in number and companies realize that the potential of algae is very high and good, it will start causing companies to look into it more seriously. And so in the next 100 years, I see the U.S. making algae farms and losing its dependency on foreign oil, which would make many Americans happy. And algae oil will become our main energy source.